Hey there guys, this video is about properties of real numbers and this is the last video for Unit 1, so we're almost there. Uh, in math class, properties are simply statements that are true for any numbers. You can sort of think of them as laws or rules that work for any numbers whatsoever. So now that we've learned about how to classify numbers into their different number sets or number families, we're going to learn some rules, and some of them will be really obvious to you. About numbers and how numbers work in math. We use properties because they are useful in justifying our steps when we're simplifying expressions and solving equations. And justifying is a really good skill to have not only in math class but in life. Anytime you state an opinion or hypothesis, it's good to be able to justify your opinion or hypothesis with facts, and so that's something we're going to be practicing here by learning these properties. At some point when you take geometry in high school, you'll be doing proofs where you'll have to justify certain statements using properties and theorems. Okay, so we'll just get into the beginning of that here by looking at these algebraic properties. So some of these you've probably seen before. We're going to start with the commutative property, and the main idea of the commutative property is that order does not matter. Okay, order does not matter, specifically with addition and multiplication. Most of these properties actually involve addition and multiplication. Okay, so let's look at some addition examples as well as some multiplication examples. So basically this means that I can take any number, we'll say A, and add to it any other number B, and I'm going to get the same answer as I would if I started with B and then added A. So the way we say that with variables is that A plus B is always equal to B plus A. The same works with multiplication. I can take any number times another number, and my product here is the same as if I started with the second number times the first. So A times B equals B times A. So with some real numbers, you can see that with 7 plus 5. 7 plus 5 we know is 12. That is equivalent to 5 plus 7, which is also 12. I could use it with variables and numbers. I could say A times B times 7 is the same as 7 times A times B. I could use it with 3x and 8. I could say 3x plus 8 is the same as 8 plus 3x. I've switched my order again on the addition. I could use it with negatives. Negative 5y times 4 is the same as 4 times negative 5y. I could say y plus 9x is the same as 9x plus y. I could even use it with a quantity, so the quantity x plus y times 3, and I could say that's the same as 3 times the quantity x plus y. Okay, so notice each time on each side of the equal sign, I switched the order over here, either of the addition or over here of the multiplication. Okay, so that's an example of the commutative property. Whenever the order switches of what you're adding or what you're multiplying, that is the commutative property. Next, we have the associative property, and the main idea with the associative property is that grouping doesn't matter. Grouping doesn't matter. And again, that's with addition and multiplication. And the main way we show grouping in mathematics is by using grouping symbols, or more commonly parentheses. So for addition, if I were to take the quantity 8 plus 9 and group the 8 and 9 together in parentheses, and then add to that 7, that would give me the same answer as if I were to keep the order the same. So I'm not going to change the order of the 8, 9, and 7, but I'm going to group 9 and 7 together instead of 8 and 9. So here I've changed my groupings, but you're still going to get to the same answer either way. Same for multiplication. If I take A times the product of B times C, and I group B times C together, that's going to give me the same answer as if I would start by grouping A times B together and then multiply by C. So here the order stayed the same, but I changed the groupings. A few more examples. I could take the quantity x plus y plus z, and then if I change my grouping and put my parentheses around y plus z, I still get the same answer. I could take 7 times 2 times 1 and group my 2 times 1. I would get the same answer as if I grouped 7 times 2 on the other side of the equal sign. I could take 7a plus 2 plus y and 7a plus 2 plus y. And over here I could group 2 plus y. Over here I could group 7a plus 2. Again, my answers would be the same. I could do 6x times 2y times 3. And group 2y times 3 on one side and 6x times 2y on the other side. Or I could group 6 plus the quantity 3a plus 1 on one side, 6 plus 3a plus 1, and group 6 plus 3a on the other side. So all of these examples, and I know I'm jotting down a lot, but I want you to see all of these examples in your notes, are representations of the associative property. Okay, it's when the order doesn't change, but the groupings change in addition or multiplication. Okay, so those are the two you're probably familiar with. The rest of these you may not know the names of, but you should be familiar with the main idea that we're going to describe. So the identity property has a pretty simple main idea. The identity property, its main idea is just that we keep the value of the number. Okay, we keep the value of the number. Well, how do you keep the value of something with addition? You add nothing, or you add 0. So 9 plus 0 is an example of the identity property. 9 plus 0 equals 9. We start with 9, we add 0, we end with 9, so we keep the value of 9. We could do x plus 0, and you still get x, so you keep the value of x. We could do 4a plus 0, and we end up with 4a. We could do negative 7g plus 0, and you end up with negative 7g. So adding 0 gives you the identity property in addition. What gives you the identity property in multiplication? Well, that's multiplying by 1. If I take 7 and I multiply by 1, I still get 7. If I take 1/4 and I multiply by 1, I still get 1/4. If I take 6x and I multiply by 1, I still get 6x. If I take negative 3b and I multiply by 1, I still get negative 3b. So whatever gives you the same as what you started with, either adding 0 or multiplying by 1, that's an example of the identity property. The inverse property, it's sort of the opposite of the identity property. The inverse property is where the original number is canceled out. Okay, the original number is canceled out. And so the way that works with multiplication, or with addition, excuse me, is if I take 10 and I want to cancel out 10, well, then for addition, I need to add to it a negative 10. I need to add its opposite. Okay, the opposite of positive 10 is negative 10, and I end up getting an answer of 0. If I take 1/2 and I want to cancel out my 1/2 with addition, I can add to it a negative 1/2, and I get an answer of 0. If I start with a negative 7, well, then what do I add to it? I add 7, and I get an answer of 0. If I start with x, then I add negative x, and I get an answer of 0. Now, I know some of you are probably thinking, why are you writing this with double signs, Mr. Jans? Well, the inverse property, again, all these properties deal with addition and multiplication. So in order to show that this is really addition, because when you're subtracting, you're really adding a negative, that's the same thing, I'm writing it with a double sign. when we go through and we do work. Of course, we don't like seeing double signs, but to show you why these are all addition properties, that's why I'm showing the double sign here. Okay, the same is true with multiplication. We do have an inverse property for multiplication, and it involves not multiplying by the opposite number, but multiplying by the reciprocal. The reciprocal of 10 is 1/10. If I multiply 10 by 1/10, I get an answer of 1. Negative 1/3, its reciprocal is negative 3. Okay, negative 1/3 times negative 3 gives you positive 1. B, the variable b, its reciprocal would be 1 over b. If I multiply those two together, I get 1. 5/4, the reciprocal of 5/4 is 4/5. Multiply those together, you get an answer of 1. Okay, so opposites involve just changing the sign and adding those numbers together. Reciprocals involve flipping the numerator and denominator, but the signs stay the same. So anytime you get an answer of 0 when adding or an answer of 1 when multiplying, that's an example of the inverse property. Okay, two more properties that we're going to look at. The property of 0. The property of 0, this is a fairly simple property to understand. It simply says that anything multiplied by 0 equals 0. Anything multiplied by 0 equals 0. So this property only applies to multiplication. So it says that if I take 5x and I multiply that by 0, my answer is 0. If I take the quantity x plus 7y and I multiply this by 0, it doesn't matter what x is, it doesn't matter what y is, my answer is 0. So that's the property of 0, or sometimes we'll even call that the zero product property. Anything times 0 is 0. Okay, the last property, and this is going to be the one we use most often when we get into algebra and solving equations, is the distributive property. And the distributive property, the main idea behind it is multiplying a value to an expression in parentheses. Okay, so an example of the distributive property would be something like 5 times the quantity x minus 2. 5 times the quantity x minus 2 can be rewritten by taking the 5 and multiplying by both the x, which would be 5x, and the negative 2, and that would just be 5 times negative 2, which is minus 10. Okay, so that's what the distributive property says. I could also do that with a 1/2 times the quantity 20x minus 4. I can take 1/2 times 20. 1/2 times 20 is 10, and say that's 10x. And then I can take 1/2 times this negative 4, and half of negative 4 is negative 2. So this is another example of the distributive property. I can do that with all variables. I can take a times the quantity b plus c. And the distributive property says that this is equivalent to the product of a and b, or ab, plus the product of a and c, or ac. And then lastly, negative 7 times the quantity x minus y. The distributive property says that this is the same as negative 7x. And then negative 7 times negative y, a negative times a negative is a positive, so this would be plus 7y. These are all examples of the distributive property. Okay, so here at the bottom of your paper, I've given you several statements, and we're just going to go through and we're going to name what property is represented by each of these statements. Okay, so number 1, we have 4 plus the quantity a plus b equals the quantity 4 plus a plus b. Notice the order of the 4a and b is staying the same, okay, but what is changing is the groupings. Over here I have a plus b grouped, and over here I have 4 plus a, so that's an example of the associative property. And specifically, this is the associative property of addition, because there's addition involved. So this is the associative property of addition. Number 2, I have 2 times the quantity x plus 9, and that's equal to 2x plus 2 times 9. Well, that's the property we just talked about above. That's an example of the distributive property. Number 3, we have 2x times 1 equals 2x. Anytime what you start with, you're taking what you start with times a number to get what you started with. That's the identity property. Okay? Or you can think about anything times 1 would be an example of the identity property, and that's the identity property of multiplication. The quantity m plus n plus 3 equals the quantity n plus m plus 3. This one will throw a few students off at first because they see the parentheses. So at first glance, it looks like associative. But notice the groupings are the same. Here I have m and n, and here I still have m and n. It's just the order changed. Okay? And because the order changed, that's an example of the commutative property. And the order changed when they were being added together, so it was the order of the addition that changed. So this is the commutative property of addition. Here I'm taking the quantity 5 minus k times 0 and getting an answer of 0. Anytime we multiply by 0 to get 0, that's an example of the 0 property, or the property of 0. Here I have 7 times the quantity w plus 3, and I'm saying that's equal to the quantity w plus 3 times 7. So I switched the order on these, and whenever you switch the order, that's commutative property, and this is actually the commutative property of multiplication. I just switched the order of what was being multiplied. Okay, these last two are just asking you to name a number in comparison to another number. So number 7 is saying name the additive inverse of 16. The additive inverse is just the number you would add to 16 to get an answer of 0. Well, that would be its opposite, so that would be negative 16. Okay, additive inverse is just a fancy word for opposite. Number 8 says name the multiplicative inverse of 3/7. And so that's just asking you to name the number you would multiply 3/7 by to get an answer of 1. This is a fancy word for reciprocal, and the reciprocal of 3/7 is 7/3. Okay, as always, if you had any questions over what we talked about in this video, make sure you've got those written down so that you can ask those the next time I see you. Until then, have a nice day. You are all wonderful people.